Welcome guys, in this video I'm going to explain everything you need to know about depth search algorithm. So I started here by creating a Java project. It has two classes, one is solution and the other one is tree node. So this one has a definition of a binary tree which includes an integer value and left and right tree nodes. So let's go back to our solution. Here in our main function we created our tree which has the values of 2, 1, 4 and 3. This is how it looks. And now let's talk about the depth research. So it's a traversal algorithm for both tree and graph data structures, and it goes deep in each branch before moving to explore another branch. So if we start from here, we go deep inside this branch before we go back and explore another branch. So this depth research algorithm has main three types. Let's write it down here. The first one is uh, pre pre-order depth search, and the other one is in order, and the last one is post order. And for all of these types, for all of them we're gonna check the left tree node first, then the right tree node. So let's write here left, then right. This for the first one as well as the second one, and the last one are all the same. We're gonna check the left value first, then we're gonna check the right value. And the difference is in the pre-order, we're gonna check the root first, and in order, we're gonna check the root in the middle, and post order is gonna be in the end. So pre-order, we're gonna do the root first, and in order, the root is gonna be here in the middle, and in post order the root is going to be here at the end. So this is the difference when we check our root. So in this example we're going to traverse through this tree, and in the first approach we're going to use the pre-order traversal, then the in order, then the post order. So let's traverse through this binary tree and add all the nodes to a list, then print this list. So first let's create this list. It has an integer values. It's called result. It's equal to new list. So after we created our list, we're gonna call our function. Let's call it depth search, give it the root and our result. Then finally we're gonna print our result. Let's go up here and create our depth search function. Let's say static. It's gonna return nothing, so it's void. Its name is depth search. It's gonna take a tree node. It's called root, as well as a list of integer. It's called result. So first of all, we have to check if the root is not empty. Then we can add the root. We're gonna do the pre-order first. So we're gonna have to check the root first. So we're gonna add the root to our result. Let's say root.add result.add root.value because it's integer. And then after we check the root, we're gonna do the same for the left child, the left tree node, and then the right tree node by calling the same function recursively. Let's give it the root left and the result, and then after that we're gonna give it the right tree node. So let's import the list right here, integer, and right here let's import the array list. So now let's go through an example. Let's say our result right here is equal. First of all, we're gonna do the 2. We're gonna add the root value to our result, which is 2. Then we're gonna go left, add the 1 to the result. Then we go left again, it's null, go back. Go right, it's null, then go back and go back again. Go to the right child and add the 4 to the list, and then go left, this one is 3, add it, and then go left, there is nothing, go right, there is nothing, go back here and check the right, there is nothing, then go back to the root and finish our result. So the result should be 2 1 4 3. Let's run our example. As you see here, it's the same. Now if you want to do the in order traversal, uh, we have to do the left first, then the root, then the right. So this one should be here in the middle. So we do the left first, then the root, and then the right. So let's go through the problem. First of all, when we start from here, we're not gonna add the root. First of all, we're gonna go left, and then left again, there's nothing, and then go back, add the root, which is 1, then check the right, there is nothing here, and go back. After we finished the left subtree, we're gonna add the root and then go right. Now right here, we're not gonna add the number 4. First we're gonna go left and then again go left. Since there is nothing here, we're gonna go back and add the root, which is 3, and then go back again. After we finish the left subtree, we're gonna add number 4 and check the right, there is nothing here, and go back and finish the problem. So right here, this is output. As you can see here, the number in is ordered. That's why it's called in order, because when we have a binary search tree and each left element is less than the root and the right tree node is greater than the node than the root, if we perform the in order depth first search, we're gonna get an ordered result. So let's run our example. As you can see here, it's the same output. Now let's do the post order depth search. Now we're gonna do the left first and the right, then finally we're gonna add the root, as you can see here. Let's go through the problem. First of all, we're gonna check the left and then the right, then go back to the root. So right here, if we start from here, we go here, and then we're not gonna add the 1. Go left, it's null, then go right, it's null, then we're gonna add the tree node and go back. Since we finished our left side, we're gonna go to the right side. After we go to the right side here at number 4, we're gonna check the left first and then go here, check the left, there's nothing, right, there is nothing, we can add the number 3, then go back and check the right, there is nothing. So now we finished both sides, let's add the number 4 and go back. Now we finished the left subtree and right subtree, now we finally add the root. So this is our result. Let's run our program. As you can see here, this is our result. And that's it for the depth first search. It goes inside each branch before moving to explore another one. These are the main types of it: the pre-order, in order, and post order. Each one we can choose the best approach depending on our problem requirement. So that's it for today. I hope you liked it, and if you did, don't forget to subscribe, like, and share, and catch me on the next one.